let us say this question on differentiability. G of x is equal to x square plus x tan x minus x tan 2x whole divided by ax plus tan x minus tan 3x if x is not equal to 0 and is equal to 0 if it is 0, that is x is 0. So it is a non-uniform function defined like this when x not equal to 0, and it is defined to be 0 when x is equal to 0, and it is clearly given that g dash 0 exists and it is equal to non-zero value, and that non-zero value is equal to b, then we want the value of b divided by a. Now what is that we have to clearly understand? This g dash 0 may be 0 value, but it is clearly mentioned that it is a non-zero value. And by considering this, now you have to solve this g dash 0. So as you all know, g dash 0 is, we have to make use of the first principle or definition. The definition is very well known to you. It is f dash of a is equal to limit f of x minus f of a by x minus a as x tends to a. Everyone knows this. Now in place of f of x, the given function I substituted here, and this is g of 0 is already defined to be 0 there, so minus 0 whole divided by, this is x minus 0 as x tends to 0. This is what the first principle we applied here. So what is that you have to understand in this case? It is given to be g dash 0 existing, and hence you have to understand it is given to be b, and very clear that b is not equal to 0. It is mentioned b is not equal to 0. Now let us solve this limit. This is, divide this with x, and thereby it becomes x plus tan x minus tan 2x whole divided by, this is ax plus tan x minus tan 3x as x tends to 0. Let us check the value now. It is 0 plus 0 minus 0 divided by a into 0, 0 by 0 form. 0 by 0 form. And this 0 by 0 form is defined to be b now. Let us solve the limit. Understand that the derivative is also the limit of a particular function. This is a particular function f of x minus f of a by x minus a. So that particular function limit must exist so that g dash 0 exists, and besides that it must be non-zero. So let us solve this limit now. Let us apply divided by x here and divided by x here, so that tan x by x, as you all know, is 1. So you can understand that limit of tan ax by x as x tends to 0 is equal to a. This is the standard limit, you know. Now, when you write that, you can understand that this b, you are getting it to be, this is x by x1, tan x by x1, tan 2x by x 2 divided by x by ax by x a plus 1 minus 3. It's clear that now you're getting 0 by a minus 2. But it is given that this is a non-zero value. This is a non-zero value, and hence you cannot take the derivative as 0. It is clearly mentioned it is a non-zero value, and hence the limit must move further, must go further. That means when you are getting numerator 0, the denominator must also be 0, and thereby you can understand that a minus 2 equal to 0 implies a is equal to 2. One value we have got. One value we have got. Now, to proceed further, to solve the limit, let us apply L'Hospital's rule. You need not have to apply L'Hospital's rule only. If you are comfortable with the expansions, you can make use of tan x, tan 2x expansions, and you can solve this problem. And like that also. Now, let me apply the L'Hospital's rule here. So, apply L'Hospital's rule. So now I'm applying L'Hospital's rule to this one. B is equal to limit of derivative of x1, derivative of tan x secant square x minus derivative of tan 2x is 2 secant square 2x whole divided by derivative of ax is a, tan x is secant square x, and minus tan 3x is 3 secant square 3x as x tends to 0. So this implies that b is equal to, now if you substitute the limit again, you are getting 1 plus 1 minus 2, which is 0 again. 0 again. But our limit must be non-zero there. Our limit must be non-zero there. That's why you have to differentiate again. So what is that to be done? Differentiate again. And thereby derivative of 1 is 0. Derivative of secant square x is 2 secant x into secant x tan x, which is 2 secant square x tan x minus, and it is 4 secant 2x into secant 2x tan 2x into 2. So 2 tan 2x. Whole divided by, again a derivative 0, it is 2 secant x into secant x tan x minus 6 secant 3x into secant 3x tan 3x as x tends to 0. Now, if you observe, again it is you are getting 0 by 0 form only. Let us now apply this formula, tan of ax by x as x tends to 0 under the limit x tends to 0 is a. So, if you apply the same limit here, let us divide the numerator and denominator with x. Then tan x by x becomes 1, and tan 2x by x becomes 2, and tan 3x by 3x becomes 3, and like that, if you substitute, this b becomes 2 into 1 into 1 minus 4 into 2, 8 into 2 whole divided by, this is 2 into 1 minus 6 into 3, 18 into 3. So thereby it is nothing but minus 40 divided by minus 52, and you can have b is nothing but it is 7 divided by 26. Now what is the value we need? We need, according to the question, we need b by a. So your b by a is 7 by 26 whole divided by 2, which is nothing but 7 by 52 is the answer. So the point to be noticed here that whenever you are getting 0 here, because b is non-zero here, the denominator must be 0, because the limit must exist and it must be non-zero. And hence we extended the problem by making a minus 2 0, which is a is equal to 2, and we differentiated again to get the value of b, and so that you have got b by a as 7 divided by 52. 7 divided